Hello guys, in this video I am going to explain the solution of question number 48 from chapter 10 of this book Engineering Circuit Analysis by Hayt, Kemmerly and Durban. So the question says that for the given circuit we need to redraw labeling appropriate phasor and impedance quantities. It means we need to convert this time domain currents into phasors, and we need to convert this inductance and the capacitance value into the impedance. So if you look at this, so over here this can be written as cos omega t, 2.5 cos omega t milliampere. It means our omega, it is 10, right? 10 radian per second. Now once we get the value of radian, so we know that the inductance, like if we have L, so the impedance will be expressed as omega L. So substituting the value of omega and L over here, so omega is 10, L is this 100 milli Henry. So it is equals to 1 ohms, right? And this is not omega, this is J. So J will also be there. So this will become our J omega, right? So simply we can replace this 100 with J omega, right? Now the next is C. For C we know that we can write it as minus J upon omega C, not equal to, but can be replaced with this. Now substituting the value, omega is 10, C is 220 into 10 power minus 3, right? So solving this particular values, this we will get minus 0.45 J ohms. So we can replace this value of the capacitance with 0.45 J omega, right? And then this can be expressed as, we know that in general, like if we have something like I am cos omega t plus theta, so we express this in phasor form like I am theta degree, right? So over here, since in this case theta is 0, so we will write this as 2.50 degree, right? And similarly over here in this case theta is minus 42, so this will be 1.5 minus 42 milliampere. This is milliampere. So it means now we can redraw. I can redraw this circuit once I get all the values. So just to have a clear picture, so I can redraw this, and redrawing it will be it is 2 ohms, it is J ohms, it is minus 0.45 J ohms. This is one current, and this current is 1.5 minus 42 degree milliampere, and this over here it is 2.50 degree milliampere, right? And over here there is a sinusoidal symbol just to indicate, this arrow indicates current source, this sinusoidal, this tilde, like it is just to indicate that the source is AC. So once we get this, so we have completed the A part. Now in the second part it is mentioned that determine expression for the 3 time domain mesh current, means we need to apply the mesh analysis, and just we need to write the equation. So in the mesh theorem, as per the mesh theorem, simply we need to first identify the loops, and then we need to assume the mesh currents, and then we need to write the equation. So in this we have 3 loops, and let the mesh currents, loop currents, let it be I1, let this be I2, and let this be I3, right? And now writing if you look at this particular first loop I1, so already we know that there is one current source, so this will be I1. So our I1, directly we can write that I1 is 2.50 degree milliampere. Similar to this, in the second loop we already have the current source, so our I2, it will be directly 1.5 angle minus 42 degree milliamperes, right? And the third one, like for this we need to write a KVL. So if we start from this, it is plus, it is minus, so we can write J, because J is the resistance impedance into I3 minus I2, right? Because I3 current is over here, I3, and I2 is in opposite direction, right? So since the loop current is in clockwise direction, so it will be I3 minus I2, right? Now coming to this part, in this plus minus, so it will be plus 2I3, only one current is flowing. And now coming to this, it is plus minus and two currents are flowing, I3 going up, I1 coming down. So this will be impedance, it is minus 0.45J, right? And the current is I3 minus I1 equal to 0. So these are the three equations for the loop, and as per the question we do not need to solve, we just need to determine the expression. So these are the three expressions. If you want to solve for the values I1, I2 already we know, and just substituting the value of I1 and I2 over here, we can get the value for I3. Right? So this is the solution for this question number 48 of chapter 10. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.